first thing it says, give an equation. Your book uses this form rx squared plus ty squared plus ux plus by plus w equals 0. The key to it is really the part where you have the rx squared and the ty squared. That's the part that's going to determine the type of conic section it is. So one of the things that you'll explore on here as we do the worksheet is I want you to find what r times t is. So in this case, r times t, well, let's see, r is your coefficient of the x squared. T is your coefficient of the y squared. Now, if you look at different books, they might use different letters for to stand for these coefficients, but that's fine. Your book uses r for the coefficient of x squared and t for the coefficient of y squared. So in this case, we'd have 4 times 5, which is 20. Okay, so I want you to find what rt is, find the value of rt, so we just did that. Compare rt to 0. So rt, how does that compare to 0? How does 20 compare to 0? Great. So, and as you go through writing more of these in standard form, I want you to look at how RT compares to 0 and the type of conic section it is, because there's a pattern that you should pick up on. So we have our general form of the equation. We want to put it in standard form. Standard form is the one where you can look at it and you tell where the center is. And if you know where the center is, then you can start to figure out things like the a values, the distance to the vertices, and instead of now going from the origin, we go from the new center. But the rules for A, B, and C still apply. That's why I define those, Scriffle defined them as A is the distance from the center of the graph to the vertex. This is going to carry over even if the center is not 0. So what we're going to do is basically get the x terms by each other, the y terms by each other, and the constant over on the other side. So now we're looking at it, and we have, I'm going to focus in on this part first. 4x squared minus 24x. We completed the square when it was 1x squared. So let's see. What could we factor out of 4x squared so it becomes 1x squared? 4, right? So we're going to factor out 4. So that's going to make 4x squared minus 6x. To complete the square, we want 1x squared. So we factored 4.
It's always going to be like ordered like that.
Yes, you always want to get it for the completing the square, the technique we learned, you want it to be 1x squared. So like here, 5y squared plus 40y, what are you going to factor out of those two? The 5, right? Because we want 1y squared. So if we factor out 5, it's 5 times y squared plus 8y equals negative 36. So now what I'm going to do is I'm going to rewrite this, leaving some space in the parentheses. And we're going to figure out what number we need to put in that parentheses so that we could write x squared minus 6x plus that number as x plus or minus some quantity squared. What number do we need in that little B number, if we're thinking ax squared plus bx plus c, take your b divided by 2 and square.
Is there any way to get that number without, like, before you factor it? No.
Take this number divided by 2 and square. I mean, because you're trying to think, how could you write this as something factor? So you're trying to think, okay, x plus or minus some number, if you square it, would move to x squared minus 6x plus something. And remember, if we had x minus, let's see, x minus n squared. Well, that would be x minus n times x minus n, x squared minus nx minus nx plus n squared, or x squared minus 2n plus n squared. So basically what you have is you have this first part. So we're trying to figure out we have this, we want to find what that square, what's that?
That was it a minus?
Oh, 2nx, yes. 2nx. So we have, in this case, here's our 2nx. We're trying to figure out what that n was to complete the square, to complete this part, so we can work back to this expression, basically. This is why we're taking -6 divided by 2 and squared. And so we get 9. Well, we want to add 9 in that parentheses. We have an equation, so we need to keep the other side equal. So I'm going to add 9 over there. Why did the equation not stay equal if I just had 9 over on the right? So not what? Right, exactly. This 9 is multiplied by 4. So we're not just adding the number 9, we're actually adding 4 times 9. And that's a kind of thing that's easy to forget. Remember, it's 9 in parentheses, so you have 4 times 9 is what you're actually adding. And then we have a similar idea here, y squared plus 8y. What number do we need to add in there? 16, right? Exactly. Okay. So then we're adding 16 in parentheses, where we're multiplying by 5, so it's really 5 times 16. Okay, so we've kept the equality because whatever we've added on the left side, we've added the equivalent amount on the right side. Well, now if we just factor it, we will get this first part, factoring it x minus 3 times x minus 3, which would be right as x minus 3 squared. And then here we have plus 5 times y plus 4 squared. Now, if you don't see how to get the x minus 3 squared part directly, just factor it the way you learned in Algebra 1, where you look at, okay, we need x and what multiplies to 9 and adds to -6. You'll see you get the same factor, so that's why it becomes the square part. Equals, let's see, -36 plus 4 times 9, so that give us 0, then plus 5 times 16 is 80. When you did all the graphing stuff last week, we have stuff, the x quantity squared plus the y quantity squared equals 80. What did we usually have it equal? 1. So how are we going to go from make this 80 become 1? Right, divide everything by 80. So I'm just going to divide
why are we doing that? I'm sorry.
Because what's our general form look like? It's x squared plus y squared
Got it.
equals one. X squared over something, y squared over something equals one. Want to equal one, so divide by e in this case. Now normally I would write the answer below this. I'm running out of space here and I'll leave all the work still up here, so it's just gonna fill up this line. So we get x minus 3 squared over 20 plus y plus 4 squared over 16 equals 1. What kind of graph does this make? Right, this is an ellipse. The nice thing is, by looking at this, you can tell the center's 3, negative 4. And then along the x, you're gonna go up, let's see, you're gonna go from 3, negative 4, you're gonna go left and right, the square root of 20 spaces to get your vertices in this case. And then from 3, negative 4, you're gonna go up and down 4 to get your co-vertices, and you could get your graph. Then you could also use your relationship between a squared, b squared, and c squared to get where your foci is. The part we're focusing on today is just writing the equations in the general form. And tomorrow we'll look at when we have this form, how do we graph it. And it's really what you did last week, just move the center first from 0, 0. I'm going to give you another one.